So this is section 6.7, and we're going to talk about exponential and logarithmic models. This section is on financial models, and the next section is on growth and decay. So the simple interest formula says that if a principal of P dollars, meaning the amount of money we're borrowing, or the amount of money we invest, is borrowed for a period of T years at a per annum interest rate, meaning every year the interest rate is R, expressed as a decimal, then the interest charged is the interest equals principal times rate times time. The amount at the end of the period, so the amount at the end of however many years it is, will be P, the principal, plus the interest, which is principal plus principal times rate times time, or more accurately, the principal times 1 plus the rate times the time. So that's for simple interest. Now, let's talk about notation for a minute. A is the amount. That is the future amount, or how much it's going to be worth however many years later, and we call it A. The principal is the amount borrowed or invested, depending on whether we're borrowing money or we're letting someone else borrow it. The rate, of course, is the interest rate per year as a decimal. It's our little r. Number, we don't see that in the simple interest formula, but we will in a minute. So that is the number of times interest is compounded per year. And that's a little n. And of course the time is the number of years. That we leave the investment for. And that's T. So we talked about the simple interest formula first. But usually money is put in an account and left to earn interest. And as you earn interest, the interest also earns interest. So that is what we call compound interest. And the interest can be compounded different numbers of times per year depending on what type of account you have. So let's scroll to the next page and we'll talk about that. So, the compound interest formula is the amount after T years equals the principal times 1 plus the interest rate divided by the number of compoundings per year raised to the number of compoundings per year times the number of years. If it's continuously compounded interest, the amount after T years equals the principal times E to the rate times time. So, how does this work in reality? Okay, well, for simple interest, there is no N. And for continuous interest, there is no N. So we're going to put not applicable there. For yearly, we compound it once a year. Quarterly means compounded 4 times per year. Monthly, of course, there are 12 months in a year, so it's compounded 12 times. And daily would be 365 times per year. So, for simple interest, we use the P plus PRT. So, if we're investing $10,000 at 4%, we have 10,000 times 1 plus the rate, 0.04, times the time, which is 10 years. And that gives us $14,000. For yearly, we're going to use the compound interest formula. So we have 10,000 times 1 plus the rate divided by the number of times compounded yearly, which is 1, raised to the number of compoundings per year times the number of years. And that gives us 14,802.44 for how much our $10,000 will be worth in 10 years. Quarterly, we have 10,000 times 1 plus 0.04 over 4 raised to the 4 times 10, which gives us $14,888.64 if we round. For compounded monthly, we're still using the compound interest formula. So 1 plus 0.04 over 12 to the 12 times 10. And this time, we crunch the numbers in the calculator. We get $14,908.33. Okay, if it's compounded daily, we have 10,000 times 1 plus 0.04 over 365 raised to the 365 times 10th power. And that gives us $14,917.92. Okay, for continuous compounding, we are going to use PE to the RT. So that's 10,000 E raised to the 0.04 times 10. And continuously compounded after 10 years, our $10,000 is worth $14,918.25. So that's all just a matter of plugging things in the calculator. So moving on to the next page. And the last page. We are not going to do this present value formula because it's just rearranging the formulas we've already talked about. And we don't need to do that because we know how to solve equations. So, how long does it take for an investment to double in value if it is invested at 4.5% per annum compounded monthly? Round your answer to the tenths. So if we put in P and we want it to double, that means our amount that we want out is going to be 2P. So we've got 2P equals P times 1 plus the rate 0.045 divided by its compounded monthly, so divided by 12 to the 12t. So the first thing we need to do is divide both sides by p, and that gives us 2 equals 1 plus, let's see, 0.045 divided by 12, whatever that is. That is 0.00375 to the 12t. So 2 equals 1.00375 to the 12t. Okay, now this is just like those equations we had in the last section. So if we take the natural log of both sides, the natural log of 1.00375 to the 12t. Sorry about all that. So anyway, natural log of both sides. Now we can bring our exponent down in front like usual. So 12t natural log 1.00375, which means that t equals the natural log of 2 over 12 times the natural log 1.00375, or approximately 0.0002 years. Ah, did not put that in the calculator correctly, guys. I was wondering why that was so strange looking. Ah, that's better. So scratch this. This should definitely be more like 15.4 years. That one makes more sense. Forgot about order of operations. Okay, and the last problem. We have $1,000 to invest at 5.5% compounded continuously. How long will it be before we have $1,200? So we want to end up with $1,200. We are starting with a principal of $1,000, and since it's compounded continuously, that means E to the R, so 0.055 times T. So first we divide both sides by 1,000, and we get 1.2 equals E to the 0.055 times T. And if we take the natural log of both sides now, natural log of E. Remember, the natural log and the E cancel each other out, so we have natural log of 1.2 equals 0.055t. So t equals natural log of 2 over 0.055, which is approximately 3.3 years. Okay, that's it for section 6.7.